Currently, I'm reading a very interesting book, Blockchain for Dummies, that is Learning Made Easy by Tiana Laurence. So, about the author is a blockchain pioneer, an investor, and a serial entrepreneur. She co-founded Factoming, a software company that builds technology within the blockchain space. She is currently a columnist for Tech Target with writings focusing on blockchain and IoT, and managing partner of the Laurence Ventures, a firm investing in technology initiatives. The back cover, that is the ISBN number, and that is it for you to read. Let me try to tell you what I read. So blockchain, it is a sort of a data structure. It's a computer science term for how to structure and share data. And today they are also known as the fifth evolution of computing. And if you see, they are a novel approach to the distributed database. So they are distributed databases that a group of individuals control and that store and share information. Okay, it's a blockchain is a data structure, and that makes it possible to create a digital ledger of data and share it among a network of independent parties. And of course, there are different types of blockchains. So there are public blockchains, permissioned blockchains, private blockchains. Once again, public, permissioned, and what is known as private blockchains. Public blockchains such as Bitcoin are large distributed networks that are run through a native cryptocurrency. Now, what is cryptocurrency? It is a unique bit of data that can be traded between two parties. And these are public blockchains are open to anyone to participate. Now, permissioned blockchains, they are like ripple control roles that individuals can play within the network. They are still large and distributed systems that use a native token. Their core code may or may not be an open source. So that is why it is known as permissioned blockchain. And then we have what is known as a private blockchains. They are known as distributed ledger technology, DLT, distributed ledger technology, tend to be smaller and do not utilize a token or cryptocurrency. Their membership is closely controlled. These types of blockchains are favored by consortiums that have trusted members and have trade confidential information. So this is at a smaller level. Is that right? That's private. And what is important is that important thing is that all three types, that is public, permissioned, and private, all three use cryptography to allow each participant on any given network to manage the ledger in a secure way without any need for a central authority to enforce the rules. So they don't need any central authority. Just keep that in mind. So that is important, that they don't have any central authority to enforce the rules. Now, the removal of central authority from the database structure is one of the most important and powerful aspects of blockchain. Now, another thing which is important is that blockchains create permanent records and histories of transactions. That is there. When data is recorded in a blockchain, it's extremely difficult to change or remove it. When someone wants to add a record to a blockchain, also a transaction, it is known as a transaction or an entry, users in the network who have validation control verify the proposed transaction. Okay. And of course, there are lacunae anyways, but generally talking, it's like this. Now, so talking about full nodes. Now, what are full nodes? Now, what a blockchain is a peer-to-peer system with no central authority managing. Okay, so we were talking about full nodes, right? So let me just repeat that it is a peer-to-peer system with no central authority managing data flow. One of the key ways to removing central control while maintaining data integrity is to have a large distributed network of independent users. This means that the computers that make up the network are in more than one location. These computers are often referred to as full nodes. So what are they? Full nodes. These are the full nodes. So what are they? The computers that make up the network are in more than one location, and these computers are often referred to as full nodes. So that is important. So to prevent the network from being corrupted, not only are blockchains decentralized, but they often also utilize a cryptocurrency. Blockchain networks produce cryptocurrencies as an incentive to maintain the integrity of the network. And many cryptocurrencies are traded on exchanges like stocks. Cryptocurrencies work a little differently on each blockchain. So the more you know about it, you will understand that better. Okay, so that is to know how, which, where, what happens. Okay, so so basically the software plays the hardware. Basically the software pays the hardware to operate. The software is the blockchain protocol. Well-known blockchain protocols include Bitcoin, Ethereum, Ripple, Bitcoin Cash, Stellar, etc. The hardware consists of the full nodes that are securing the data in the network. So the nodes are the computers that make up the network are in more than one locations, and they are known as nodes. So full nodes. So the hardware consists of the full nodes that are securing the data in the network. Okay. And so again, fifth evolution, I've already told you that blockchains are recognized as a fifth evolution of computing because they are a new trust layer for the internet. Okay, so that is there. Now, why do you think that they are important? Blockchains are important because they allow for new efficiency and reliability in the exchange of valuable and private information that once required a third party to facilitate, such as the movement of money and the authenticity of identity. This is a big deal because much of our society and economy has been structured around establishing trust, enforcing trust when it's broken, and the third parties that facilitate trust. So there's so much to do with trust which is not there, and how to enforce it. So you can imagine how this simple software can be utilized to fix areas that have proven to not be foolproof, such as voting, supply chain management, money movement, and the exchange of property. So talking about blockchains, what is the structure of the blockchain? It is slightly, each blockchain is structured slightly differently. However, Bitcoin is a great blockchain to study because it was used as a template for most subsequent blockchains. The data on Bitcoin is structured so that each full node, you know what's full node again? The computers running on the network, contain all the data in the network. This model is so talking about this, it is the model is great from a data persistence point of view. It ensures that the data will stay intact. It ensures that the data will stay intact even if a few of the nodes become compromised. However, because every node has a full copy of the history of transactions since the very beginning and every transaction in the future, it requires that the entries be as small as possible from a storage capacity point of view. So that is like the structure of the blockchain. So there are three core elements. Now what are they? The way the Bitcoin coordinates the organization and input of new data comprises of three core elements, and one is a block. Now what is a block? It is a list of transactions recorded into a ledger over a given period. The size, period, and the triggering event of the blocks is different for every blockchain. Now what is chain? That's block. Now what is chain? A hash that links one block to another mathematically, chaining them together. That means a hash in blockchain is created from the data that was in the previous block, and the hash is a fingerprint of this data and locks blocks in order and time. Okay, and of course blockchain network. So what are networks? The network is comprised of full nodes. Full nodes, think of them as computer running an algorithm that is securing the network. Okay. Each node contains a complete record of all the transactions that were ever recorded in that blockchain. So, and of course, the nodes are located all over the world and can be operated by anyone. It's difficult, expensive, and time consuming to operate a full node, so people don't do it for free, etc. We won't go into that. The terms Bitcoin and blockchains are often used interchangeably, but they are not the same. Bitcoin has a blockchain. The Bitcoin blockchain is the underlying protocol that enables the secure transfer of Bitcoin. The term Bitcoin is the name of the cryptocurrency that powers the Bitcoin network. The blockchain is a class of software, and Bitcoin is a specific cryptocurrency. Okay, so that's it, and let's just talk about blockchain applications. So what are they? So blockchain applications are built around the idea that network is the arbitrator. This type of system is an unforgiving and blind environment. Computing code becomes law. The rules are executed as they were written and interpreted by the network. Computers don't have the same social biases and behaviors as humans do. So that is the difference. Okay. So, because the network can't interpret intent, at least not yet, insurance contracts arbitrated on a blockchain have been heavily investigated as a use case built around this idea. And very important thing is impeccable record keeping. If you're talking about this, that's an interesting thing that blockchains enable. That there is a record keeping is to the T. They can be used to create a clear timeline of who did what and when. Many industries and regulatory bodies spend countless hours trying to assess this problem, and blockchain enabled record keeping. So now let me just talk about the blockchain cycle. The blockchains originated with the creation of Bitcoin. It demonstrated that a group of individuals who had never met could operate online within a system that was sensitized to cheat others that were cooperating on the network. The original Bitcoin network was built to secure the Bitcoin cryptocurrency. It was around 5,000 full nodes and is globally distributed. It's primarily used to trade Bitcoin and exchange value, but the community saw the potential of doing it a lot more with the network because of its size and time-tested security. Then we have what is the Ethereum network, is a second evolution of the blockchain concept. Okay, so this is it, Ethereum network. It takes the traditional blockchain structure and adds several new programming languages that are built inside of it. Like Bitcoin, it has over 10,000 full nodes and is globally distributed. Ethereum is primarily used to trade Ether and create smart contracts. So the most popular Ethereum smart contract is the ERC20. It allows for the generation of interchangeable tokens. These tokens can be used for fundraising purposes. Okay. And of course, another important third evolution in blockchain technologies that is under active development is addressing speed and data size constraints. Fixing these issues will enable blockchain technology to be used more realistically with mainstream applications. So that is there. Now, so again, just a little, why blockchains are getting popular? Because they are powerful tools, because they create honest systems that self-correct without the need for a third party to enforce the rules. So they don't need any whistleblowers. They accomplish the enforcement of rules through their consensus algorithm. Now, consensus, what does it mean? It is a process of developing an agreement in the blockchain world. So developing an agreement among a group of commonly mistrusting shareholders. These are the full nodes of the network. The full nodes are validating transactions that are entered into the network to be recorded as part of the ledger. So this is a short, it shows the concept of how blockchains come to agreement. Just have a look. A user requests a transaction. The request is transmitted to the network. Third, the network validates the transactions, or the transaction is not accepted, it's kicked out. Then the transaction is added to the current block of transactions. Then the block of transactions is then chained to the other blocks of transactions, and the transaction is confirmed. So once again, let me just show you that how does it work. A user requests a transaction, the request is transmitted to the network validates the transactions or refuses, or it's just kicked out. The transaction is added to the current block of transactions, and the block of transactions is then chained to the older blocks of transactions, and then the transaction is confirmed. And today there are thousands of blockchains and blockchain applications in existence. The whole world has become obsessed with the idea of moving money faster, incorporating and governing in a distributed network, and building secure applications and hardware. So if you say why are they popular, because the popularity is because they believe in moving money faster, incorporating and governing in a distributed network, and building secure applications and hardware. So that is why blockchains and blockchain applications are mushrooming or getting popular all over. So if you're talking about, so once again, most up and running blockchain applications revolve around moving money or other forms of value quickly and cheap. So, well, that includes what? Trading public company stocks, paying employees in other countries, and exchanging of currency, one currency for another. So that's it. Then another thing is, and today blockchains are also being used as a part of a software security stack. Then you have the ICO. What is that? Initial coin offerings and another existing blockchain innovation. They are a type of smart contract that allows the user to offer a token in exchange for investment funds. So that is there. And one of the fantastic innovations inherent in the ICO, that is so self-clearing and self-settling instruments. That's what is important. So just to let you know that blockchains today have laid a foundation where the need for trust has been taken out of the equation, where before asking for trust was a big deal. With blockchains it's small. Although the infrastructure that enforces the rule, if the trust is broken, can be lighter, much of society is built on trust and enforcement of rules. The social and economic implications of blockchain applications can be emotionally and politically polarizing, because blockchain will change how we structure value-based and socially based transactions. So in a way, it is more ethical. Like, there is trust it's like enforced trust. You can't do without it. So if you see from that angle, that they have laid the foundation where the need for trust has been taken out of the equation. It is there. You don't have to make separate people or separate departments to enforce that. It is there. So, nice book to go through. Just go through this book, read it, enjoy it.